Thank you very much, Nancy. Yeah, so just to say, I'm going to give an overview of the satellite market, if you like, all the different systems that are available. And then after I speak, then Charlie Lever from Iridium is going to talk about their service offering. And then we have Jonathan and Shelley from MITRE who are going to talk about some exciting new developments in high latitude marine satellite terminals. I think I've got that more or less right. I just thought I would, before I go too much further, just explain to you guys, you folks, who is this random British guy? Why is he here? And also to say that I've done my best to translate to American, but if there's something I've missed, please stick your hand up and I'll explain. I hope to introduce you to at least 2 new British expressions that you may not be aware of. So I'm with the School of Earth and Ocean Sciences in Cardiff University in Wales. But my background, I'm an electronic engineer. I started my career at the BBC working as a broadcast engineer, and then I went to work for the British Antarctic Survey, and I went over on a research station. I looked after communications equipment there, and then I did a PhD with BAS on Antarctic HF radio. I worked in the private sector for a while, and then I've ended up back at Cardiff University, where I now build instrumentation for studying glaciers, or glaciers, as I had to explain to the border control officer when I was coming to the US, because he was like, I study glaciers, what are those? Oh, sorry, glaciers, okay. I'd also mention in passing that I'm a member of Pride in Polar Research, which is a networking group for people, LGBT people working in polar research. There we are. So it's an exciting time to be in satellite, particularly for those of us with an interest in the polar regions, everybody here. We have new launch vehicles and new satellites, and we have new terminal technologies. This Keynote flat panel antenna is a flat panel that replaces the traditional parabolic dish, which is more convenient. This is a new development, and we have new companies and new services coming from existing providers. So after quite a long period in which the satellite community was very, very static, and most of the innovation and new stuff that was going on at mid-latitudes and was not really accessible to people in the polar regions, suddenly we've got a great outpouring of new ideas and technologies. And the key message I wanted to kind of put across is that over the history of satellite industry, everything is getting smaller and smaller. And so starting with the kind of organizations that were involved, back in the early days, everything was done by governments. And it was the USSR and the USA to begin with. And in fact, we had other countries wanted in on it, and it was done by an intergovernmental process because it was so expensive. And that was actually the history of both Intelsat and Inmarsat. They were both intergovernmental organizations before they were privatized. And then we had the sort of era of the big corporates. So SES in Luxembourg is the world's biggest satellite company by value. They are a $2 billion company. Inmarsat is a $1.5 billion company. Intelsat and Iridium are both about $500 million, give or take. And these were, big corporate companies. It was big investment that was required. But now we're starting to see what I've called the specialists, and I picked 2 here. Basically, these are companies I know, but Spire is a company who specialize in collecting data from ships, from the ship's AIS transmitters that are telling other shipping what's going on. Spire satellites pick up this service, and they aggregate it to create a global picture of shipping. Kepler is a specialist company providing data services, particularly to people in the polar regions, but also in remote regions. But these are companies that are new and that have real customers. But they've found a little niche or niche in the market. So, and then finally, and I hesitate to say this slightly in Denver, but we have, I'm a point ahead of myself. We actually have proper startups which are still not fully in the stage of having real revenue. They're burning their investors' cash trying to get to market. And I've picked Hyber here as a Dutch company, again, trying to provide a low-cost IoT service. But as you will see in a later slide, there are a whole load of competitors all going at that same space. And finally, yes, as I say, didn't want to say this in Denver, but we also have cowboys in the pejorative sense of the word. So Swarm is a US company, and they put satellites into orbit without permission and broke the law in the process. And so we're now in the situation where access to space is cheap enough that people can do it in an unauthorized manner, and that we might actually have to have some kind of comeback or policing for people putting stuff in orbit that they're not supposed to. And I guess they did this on the any publicity is good publicity kind of model, but yeah. Space pirates, space cowboys, however you want to think of it. And the other sort of side of this kind of continuum is that the satellites themselves are getting smaller. And I've got some sort of comparisons here. So a typical geostationary satellite, the sort of thing that's providing a service from Inmarsat, weighs about 7 tons. That's about the size and weight of an unladen school bus. And then we come down in size. So Iridium's next satellites, they weigh about 900 kilos or 2,000 pounds, which is the size of a small car. And for this, in European terms, is a small car. In American terms, this means the satellite is small enough to go in the back of your pickup truck. 10 years ago, 15 years ago, I went to talks about small satellites, and we were talking about 100-kilo satellites, the size and weight of a washing machine. And there was a British company in particular who worked pretty hard on pioneering this concept, and that was considered small at that time. And there are Earth observation satellites in that kind of class. And then now we have much smaller satellites. Now, Hyber's satellites, Kepler's satellites, they are 6U CubeSats. The CubeSat format was originally a 10 centimeter by 10 centimeter by 10 centimeter cube, and they multiplex up to make bigger satellites. But that's the size of a small desktop PC. You know, that's not a big piece of hardware. And then sort of finally, so Swarm's illegally launched satellites are the size of a pile of beer mats. They're 2.5 centimeters, an inch high, and whatever it is, 10 centimeters, I can't think what that is in inches. But yeah, the size of a pack of beer mats. So things are getting smaller and more accessible, and there's more diversity and variety as a result. So I've always had a little bit of an issue with pitching this talk, because obviously there are some people here who are satellite professionals and some people here who are kind of vaguely aware that satellites are in space. So a kind of quick recap of how this works. So I'm going to talk about orbits very briefly. The kind of best understood type of satellite is the kind that brings you satellite TV or satellite internet, if you have that, which is a geostationary satellite, which means that it's orbiting in the same period that the Earth rotates. It takes 24 hours to go round, and that means from our point of view, it appears fixed in the sky, we point the antenna at it once, and we don't worry about it again. And that has a lot of advantages. You can use a big fixed high-gain antenna. You don't need a tracking system if you're on land. You can get lots of bandwidth. There are loads of people offering this service. The challenge is it's a high altitude, so there's a high latency. The speed of light means you have at least a quarter of a second delay, which, going back to what Martin was saying earlier about round-trip times causing trouble for networks, that's geostationary's inherent problem. And that's your TV correspondent on the news, having to wait a quarter of a second behind the anchor person. You also get no high latitude coverage, although the MITRE folks are dragging this up beyond 80 degrees, but it used to be that the highest latitude Earth station was at CFS Eureka at 79.9 degrees north, and beyond that, because the satellites are over the equator, the curvature of the Earth makes it very difficult. And very broadly speaking, we then have low Earth orbit, which is a whole, geostationary orbit is one thing, low Earth orbit is a whole family of different orbits in different inclinations with different periods, but essentially relatively close to the Earth. The satellite is always moving from the perspective of being on the ground. So if you want a high-gain antenna, you've got to have a tracking system. Now, if you're on a ship, you don't really care because you have to have a tracking system anyway, but on land, that was previously quite expensive. Traditionally, that meant limited bandwidth, high cost, but low latency and pole-to-pole coverage. I'm going to plug a website now called Stuff in Space. If you have your laptop, type in stuffin.space into your browser and have a look. It was written by a student a couple of years ago, and it creates a really nice way to look at orbits. I've just sort of grabbed a couple here. This is what the Iridium constellation looks like, and here with Antarctica with the South Pole in the middle. And you can see that the satellites are in polar orbit, so they all pass over the pole, which means from our point of view, we get great coverage. just another illustrative example. This is the current state of Elon Musk's Starlink constellation, and they've launched in planes that serve the mid-latitudes and don't currently serve the poles. So looking at the Arctic here, there's a big hole over the North Pole. So I'm going to kind of trot through quite quickly the sort of geostationary options available to you. And the big one really to start with is Inmarsat. All of their services currently are served from geostationary satellites. So when I worked for the British program, we had Inmarsat at both Rotherham Station at 68 South and at Halley Station at 75 South, and they were off-the-shelf installations and worked fine. But really, you go poleward of 75, it's much harder work to work with Inmarsat. But it's a straightforward off-the-shelf service, and they offer the full range of different services from sort of little IoT-style services right through to high-volume, high-bandwidth. Telecom satellites. So these are the same satellites that bring you your satellite TV, that are providing the news links back in the days when I worked for the BBC. And you basically buy transponder time on these satellites, and this is the sort of bulk way of buying satellite airtime, and they come in different frequencies. And these are broadly characterized in bands: the C band, which is relatively low, 4 to 8 gigahertz, KU band, which is the sort of thing that you have for satellite TV, and KA band, if you came here on a plane, I came on an American Airlines plane with a nice high-speed internet to the aircraft, that's at 26 to 40 gigahertz, the KA band, which was pioneered by the Canadians, but has picked up since. And so the difference with these different frequencies, essentially higher frequency means a smaller antenna, but you also have more risk associated with rain and snow affecting the propagation of the signal. C-band is more robust, but the antenna is physically bigger. You also get more bandwidth as you go higher in frequency. Part of the change and introduction of these new frequencies has come about because the power amplifiers that are needed to produce the RF signal have got better. When I was at the BBC as a junior engineer, we were using traveling wave tube amplifiers, which is basically a glass valve to produce enough power at that frequency. Now it's all solid state. The other one I'm going to mention, this is the sort of Cinderella service of scientific satellite communications, which is DCS, which is the very imaginatively named data collection service, sometimes called DCP, Data Collection Platform. And this comes out of the world of meteorology, but it's actually used beyond that. And it's carried by geostationary weather satellites. So the NOAA GOES East and West satellites, Meteosat 8 and 9, and Himawari 8, and also satellites run by India, China, and Russia. And this is unusual because it is free. If you are a scientist, you can send small amounts of data through this service, and as long as you share your data freely, you get free access to the satellite. And this is one of the ways that remote weather stations are connected. Lysanias Broyles from the US Army Corps of Engineers gave a great presentation at a conference I organized a couple of years ago, showing how in the southern US, this service was being used to collect weather data during major hurricanes, and that the service carried on working through the path of the hurricane, despite the fact that the terrestrially connected sensors that they had all been knocked out because the terrestrial networks had gone down because of power failures. So DCS is an old system, but it's worth bearing in mind. If you are collecting a small amount of data and you're in range of a geostationary satellite, it's well worth looking at. Moving on to satellites in polar orbit, which are obviously relevant to this audience. Argos is a French-American system. It's run by CLS in France, but it was developed jointly with the US. And Argos is a system which traditionally was used by the marine community for tracking floating buoys, and also used increasingly these days for tracking animals and birds. Argos's kind of unique selling point is that they have very, very small, very, very lightweight transmitters, very low power. You don't get very much data. It's only just at the point at which their bidirectional service is coming on, but you want to collect a small amount of data from an albatross flying over the Southern Ocean. Argos is the only show in town. CLS are in the process of beefing up Argos because traditionally it was run on a kind of semi-commercial basis, and now that the world of everyone's kind of into the idea of satellite Internet of Things service, they realize that they've been running one for 30 years and that they could resell their existing service to a new market. And they've rebranded it as Keynote, and they will be launching new satellites and new terminals, and they promise me that their costs will come down. One thing to mention about Argos is that they have a special tariff for scientists, which is called the JTA, the Joint Tariff Agreement, and Eric Locklear at NOAA runs that. Gosh, I have not timed this well. So a couple of others to mention. Gonets is a Russian service. Iridium, we all know and love. Kepler is a new service run out of Canada, which is basically like an orbiting USB stick. You upload your data as the satellite passes over, and it downlinks somewhere else. This is kind of the big thing I wanted to say for the new companies that are coming. There are a lot of new entrants, and it's quite difficult to work out who's doing what. There are a lot of people who are not yet in orbit, but talking a good game. There are a lot of people who are in orbit, doing demonstrations and tests, but are not yet offering a commercial service. And then there is OneWeb, is the only firm I can find who are doing customer trials in the Arctic. But basically, all of these companies are trying to offer some kind of polar-based service that may or may not be useful in the future. It's very difficult to work out exactly what's coming. And what I would say to you, as someone who bought a development kit from one of these companies and is still waiting for the service to go live, be skeptical of service launch dates. Don't believe that something will launch when it says it will. A very quick kind of think about a buyer's guide. If you want to buy satellite service, think very clearly. This is a good engineering principle, but in general, what is important to you? What kind of service do you need? Do you need coverage all the way to the pole? Do you need it to work on a ship? What kind of data? What kind of power consumption? What's the limiting factor? And if you're like, I'd like all of those things and I'd like it all for nothing, remember, you can't have the moon on a stick, as we say in the UK. You can't have everything you want. To mention briefly, we have messages, or some services are message-based, like sending a text message. Some are stream-based, like making a phone call. So you need to think about which service is appropriate to you. If you are very low power, you are basically constrained to a message service only. So Argos, DCS, the IoT-style services are all message-based. If you have more power and a bigger terminal, then you can have a real stream. Installation issues. Remember, your terminal needs to see the sky. And this is actually surprisingly important. If you work in a valley, the terrain cuts off, and you're talking to a low Earth orbit satellite, the terrain cuts off the window in which you can see the satellite. This is why your Iridium phone drops calls when you're deep in a valley, because the satellites are 10 minutes to horizon, and if it doesn't see the next satellite at the point it needs a handover, it drops the call. Consider a terrestrial radio link. Put the antenna somewhere high up and run a terrestrial radio link to it if you need to. Beware of snow and rime ice. I was once woken up by the night watchman when I was working on the British program because snow and ice had built up on the radome of our VSAT terminal, and it was actually depolarizing the signal and causing interference to other users on the satellite. And the satellite network operator rang me up and said, do something about it and do it now, because you're spoiling other people's service. I had to go outside, switch the power amplifiers off, and bang the radome with the stick until the snow came off it, but that was all was necessary. I can't stress this enough. Make sure you have adequate peak and average power. Satellite generally uses a lot of power while you are transmitting, so you need to have a lot of power available at once. If you buy the small Iridium modules, you'll find they have a whacking great supercapacitor in them in order to provide enough power to provide a burst of power out to for the transmission. So your average power and your peak power can be quite different, and the power supply design needs to be able to cope with that. Everyone asks about price, especially scientists. Free is sometimes an option. DCS is free. Argos, as I said, had a special tariff for scientists, but talk to your salesperson. The price can often be negotiated. If you are operating multiple terminals and you can pay in advance and you don't want a monthly bill, you can often get a better price. You buy a package of airtime, you bundle everything together, you make your business worth having if you buy it in big chunks. New opportunities created by the new satellite connectivity that's coming. It'll become much less hassle to connect stuff with satellite. Once we have these newer services online, it will be straightforward and we won't think about it being a big hassle. And that means we can do real-time data collection much more readily. From a logistics point of view, we can actively track people and vehicles. You can do this with Garmin InReach now. There's also a British company called Rock7 who provide a fleet-managed set of InReach-style terminals so that you could actually look after 100, 150, 200 terminals from a single dashboard and see where everybody is. You can do enhanced logistics. The logistics sector, commercial logistics sector, is increasingly tracking shipping containers by satellite. Beware the social changes that arise when you start collecting large amounts of data about where people and things are. Beware the tendency to micromanage. So I'm out of time, but thank you all very much. I'm just going to mention that I do this work with the World Meteorological Organization, running this group called SATCOM Forum, which intends to bring together scientists and the industry. And we have a nice website. We have a conference every 2 years. The next one should be next year. And we also publish a handy guidebook, which is everything that is currently in commercial service that we know of. So if you want to look up how to buy a satellite service, have a look at that. Thank you very much.